here. So a little bit about myself. I'm a security engineer at Databricks. Previously, I've worked at companies like Stripe and Datadog, and I have over 15 years of experience in security Toil. Let me just see a quick show of hands. Who here has been on call in some capacity for their work? Right, okay. Well, this talk is for you. I have been on call a lot. I've been on call for vulnerability management teams, for detection engineering teams. I've also taken the pager for services, service outages, things of that nature. And being on call really sucks sometimes. And so this talk is just how I have tried to make life a little better for me and my coworkers. So in this talk, we're going to talk a bit about how at Databricks we reduced the incident investigation time for service issues from around 15 minutes to under 2 minutes in most cases. And this talk is really about the practical implementation of MCP servers for security operations. So if you toyed around with LLMs or MCP servers in the past and you're interested in how to potentially use them in a corporate environment, we'll touch on all of that. We're also going to talk a little bit about some of the challenges of using MCP in multi-cloud environments. So I thought it'd be good to kind of level set by talking about operational toil. And I asked my good friend Claude here if he could define operational toil for me. And I actually think this is a pretty solid definition. The thing that really stands out to me about this definition is the emphasis on manual and automatable work. If we're doing something that involves us to put our hands on keyboard and to stop what we're doing, and if it's something that can be automatable, I found that to be frustrating, and I think that's something that, you know, as an industry, we like to work towards a state where the computers are working for us. We're not working for the computers. I've also found that during on-call rotations, we rarely have time during the rotation to implement a lot of the changes or a lot of the automations that are needed to make life better. And ultimately, this becomes tech debt. And we all know that tech debt is notoriously difficult to pay down. So on-call rotations, by their nature, are interrupt-driven, and we all know that when you're working on a project, you're pulled out of that project because you received a page, suddenly you're looking into an alert or an incident. It's exceptionally disruptive to our productivity. And there's a workplace researcher at UC Irvine named Gloria Mark, who did a bunch of research about a decade ago into workplace interruptions. And she found that it takes about 23 minutes for an employee to regain their focus on the task at hand after they're interrupted. And I'm sure that many of you, if you work in an office, have had that experience where you're in the office Monday morning and your coworker comes by and wants to ask how your fantasy football team did, when really you're just trying to focus on whatever project you're currently working on. And it's very hard for our brains to pause on one task, to quickly switch to something else, and then to switch back. And Ms. Marks found in her research that these impacts on our kind of cognitive context tend to compound. So the more that we get interrupted, the harder it is for us to refocus on whatever task we were originally working on. And I think this is really exacerbated in the cybersecurity industry. As a detection engineer or a security engineer, we have to kind of build complex mental models around threat actor TTPs. We have to understand service architectures and network topologies. So when we're constantly getting pulled into other types of activities when we're on call, it's just exceptionally disruptive. And at the end of the day, I think a lot of this leads to burnout, which we know is a huge challenge in our industry. So what are some things that we can do to address that, right? Well, the first thing is we need to look at what we're doing today. And if you look at security teams today, I think we'd all agree that a lot of security teams scale unevenly. And when I say unevenly, I mean that kind of regardless of your expertise, your background, your tenure in your career, what I've found in my personal experience is that someone who's been at a company for 2 or 3 years is going to be more effective at responding to security incidents than someone who's been there for 3 months. And in the past, we've tried to address this through playbooks. But playbooks are really an 80-20 solution. They require that we kind of tabletop or imagine all of the different ways that we'll need to investigate an incident or respond to a scenario in our environment. But that 20% is where we really struggle, the 20% that we haven't anticipated and we haven't accounted for. They also require continuous upkeep. Rarely have I used a playbook that didn't need some kind of update or some kind of tune in some way, and this all just becomes tech debt that, again, is really challenging to maintain in the heat of the moment. Finally, I think it's important to point out that, like, when we're working with a playbook, we still have to fundamentally understand the problem that's at hand. So if you get an error message or you're working an incident in a technology that you have no understanding of, even if you have a great playbook, you may really not know how to use it or how to operate it. And so these are all challenges that we have to deal with. When we're thinking about cybersecurity incident response, to me, the person that has the pager is really seen as the first person to the scene of the crime. So if you want to make an analogy to an EMT, the EMT is at the scene of the accident as quickly as possible, and their job is to stabilize the patient and ensure that they get any critical care that's needed right away. But it's not their responsibility to take that patient from the moment of the accident and work them through the long arc of their recovery. And in incident response, we're functioning the same way. When we take the page, it's our job to triage the incident as quickly as possible, to try to understand the what and why of what happened, and ideally reduce the cognitive penalty that we're paying when we're pulled out of the other work that we're trying to do. So what does an ideal incident triage solution look like? To me, in my experience, an ideal solution can quickly get to the what and the why of a security incident, regardless of whether you're troubleshooting a failed service or some kind of alert that's been triggered in your SIM. Getting to know the what and the why is very, very important, because ultimately, as the first responder, you need to have that context to understand how to escalate the situation. I think it's also really important that a solution shows its work, particularly in the age of large language models where we have concerns about hallucinations. It is really, really important that when you are reviewing what's happened in an incident, you can understand exactly how a triage solution has reached the conclusions that it has. And finally, I think a good triage solution needs to tell you what to try next. It doesn't have to necessarily solve the problem for you, but being able to point to the next steps that you should take to investigate an issue, the next potential set of questions that you should ask of the system, ultimately is going to make your incident response process much easier. So what does this have to do with Databricks? Let me tell you a little bit more about our detection and response environment at Databricks and how we've been able to use some of these tools to help us out. So Databricks is a multi-cloud company. We are, as a security team, performing continuous monitoring across AWS, Azure, and GCP, plus a few other kind of custom environments. We are monitoring over 50 cloud environments. And in each one of those regional deployments, we have hundreds of batch and streaming jobs that are supporting thousands of individual detections. Everything from detections that are monitoring logs from CloudTrail to endpoint-based detections. And things go wrong, right? Anytime you're operating at that scale, there's just a host of issues that are going to come up. The first and probably most common issue is delayed log delivery, right? We have an upstream provider problem. Particularly, we see this with SaaS products where there's either a gap in logs or a delay in log delivery. We also have cloud provider outages. I think we all got a reminder about that on Monday of this week. And then we also have artificial issues, right? We have quotas and rate limits. So if you find that your workloads do really well on one instance type in most AWS regions, that instance type may not be available everywhere. And so every region's a little different, and we have to be able to account for that. And finally, people make mistakes, right? How many of you have ever shipped code that's broken something in production, right? Okay, that's right. There's probably more of you than raise your hands. But yeah, I've broken production. People break production all the time. And this is despite the fact that we have unit tests and integration tests and CI/CD. These are just things that happen. So like I said, we have this regional deployment model. If you can imagine, 50 of these regional workspaces, all funneling data into really common security operations tools, PagerDuty, Slack, and Jira. And then ultimately when something breaks, it goes to my phone, and then I'm really sad because I have to stop what I'm working on and pivot to a new project. So here's a very kind of common case study of just a failed Spark job in a single region, just to give you a sense of what it takes to kind of dig in and investigate one of these problems. So first of all, I have to pull out my phone and acknowledge the page, right? Click the button on my Apple Watch, click the button on my phone, and then I have to log into PagerDuty and pull up the incident. I got to find the right incident, and then I have to read the error message. I got to figure out which region is involved, and potentially which job is implicated or which data source. Then I got to open up a whole new set of browser windows, and I got to log into that region. I got to find that job. I need to find the most recent execution of it or where it errored out. And at that point, I'm like 5 or 10 minutes into this process. I've completely forgot what I was working on before I got the page. And I'm reading an error message about delayed log delivery or US East 1 having a problem. And then after I grok all of that, I have to actually decide what to do next, right? Is this a job that I know a coworker was recently working on when they were shipping new detections, so I should just ping them and see if they can help out, or do I need to escalate this to a different team? And it's just really frustrating. And like I said earlier, I think the computer should be working for us, not the other way around. And earlier this summer, I just had a really terrible on-call rotation. There was like one single day where I got paged like 60 times. And I just got to the point where I was like, I'm not doing this anymore. There's got to be a way to improve this process. And so I committed to myself that during my next on-call rotation, I was going to do everything I could to use AI-assisted tooling to try to make this less painful and more consistent across the entire team. So when I started down this road, my first thought was like, I'll just use an LLM to solve all of these problems, right? And an LLM makes sense for a lot of reasons. So they have the ability to consolidate a lot of different disparate pieces of information into a cohesive story that tells us a lot about our triage process. They have the ability to traverse complex code bases. So at Databricks, we use detections as code. We also have infrastructure as code. And so I'm able to expose all of that content directly to the LLM. So when it's reading an error message, it can actually go in and then look at the source code itself to try to see if it can identify the specific problem. And finally, LLMs have a lot of subject matter expertise, right? They know a lot about computers, and even though they get things wrong occasionally, they can generally point us in the right direction, particularly if we're dealing with something that we don't have a lot of experience with ourselves. So my kind of like back of the napkin drawing of how this would work would be, some kind of operational agent, some kind of solution that had the ability to reach into all of our regional workspaces, to reach into Slack, to reach into Jira, and to really be able to give us the information that we needed to triage incidents faster. So about a year ago, Anthropic released a open specification called the Model Context Protocol. And this is designed to be a data interchange between large language models and services and tools. And essentially, what this allows you to do is to define functionality. To make an analogy, you can essentially define a Python function where the function accepts input, does something, and then provides output. And we're giving the models the ability to discover these functions and then to invoke them on our behalf. And this was kind of a huge hit as soon as it came out. These are some screenshots from the Model Context Protocol GitHub page from a few weeks ago. These are just a few of the MCP servers that have been released. And as you can see, it's everything from MongoDB to Microsoft Teams to all kinds of AWS and GCP services. Like I said, we're using Jira and PagerDuty. They all have great support. And so these are essentially tools and functionality that enable these LLMs to reach into these services and interact with them much in the same way that we would, or you would if you were interacting via an API. This hasn't been without its problems, though. The Model Context Protocol domain, specifically with AI and cybersecurity, has been very, very active. There have been a lot of findings, and I would say that as a community, we're still learning like how to safely use these tools. We have had multiple issues with supply chain attacks where we've had MCP servers get compromised in some way and they're suddenly exposing information to outside sources, or data is being leaked in a way that we didn't intend. And so if these are solutions that you're going to investigate, I would just encourage you to tread lightly, and certainly when in doubt, use them in a read-only context, right? So I'm not recommending that you allow these tools to kind of run rampant in your code base without supervision. But they are really effective. So here's an example of one of our integrations that we've set up with PagerDuty and Databricks. This was kind of like the first version of my incident response agent that I wrote. And as you can see here, in this specific instance, I have Claude pulled up, and I just say, hey, can you investigate this PagerDuty incident? And I give it the ID number. And then what we see is Claude goes in and logs into PagerDuty on my behalf. It pulls a list of incidents that are assigned to me. It's then able to figure out that the specific incident that I've referenced is an issue in US West 2. And then I've given it the ability to log into US West 2 and take very specific actions related to troubleshooting. So the ability to see what's running in that environment, the ability to see the status of the jobs, the status of the workloads that are there. And it goes in and takes all of these actions autonomously. The only information that I have given it is the PagerDuty incident number. It then goes in and gives me a really solid summary of what happened. So in this case, we have a Spark job that is running a lot longer than it's supposed to. It's supposed to execute on a 15-minute time window. We're bringing data in, we're analyzing it for security purposes, and when you have a sudden surge in data, sometimes jobs will take longer than that, and it results in a problem. And so it goes in and it's done an analysis of all of the historical executions of this job and just given me, frankly, some really useful information that would have taken a lot of time for me to collect in a very short time. It also goes in and gives me some next steps and some recommendations, right? So based on the incident, the error message, the context that it's collected, it's gone in and said, hey, like maybe you should troubleshoot next by reaching out in this specific service, consider rescheduling the job so it runs on a different schedule and things of that nature. Now, why does this matter with productivity, right? So like I mentioned, if I'm getting paged 50 times, I don't have 10 minutes to go through and respond to every single page and figure out what's going on. So at a minimum, a solution like this allows you to speed up your response time, right? If you integrate this with your SIEM, your SOAR, any of the kind of internal security tools that you're using, you have the ability to basically respond more quickly. The other thing that I like about this is it has allowed us to completely change the way that we manage our PagerDuty schedules. So a lot of the SLAs that we are dealing with internally are typically like an hour for something like this. And so we've been able to reschedule the way that alerts get delivered so that I can have 30 minutes of kind of like time when I'm not being paged and I'm not being bothered, knowing that if we do get slammed with pages, I'm going to be so effective in that next 30 minutes that I've devoted to triaging alerts and triaging pages that it's not going to be a problem. So this essentially allows us to focus more on our day-to-day work, our project work, the things that we're responsible over quarters or months, as opposed to kind of constantly fighting that battle. So just a few more kind of ideas that I want to see with you around how we're using MCP in our environment and how it may be helpful for you. So there are a few other ways that we are leveraging MCP for detection and response. So first, we found that large language models, if they have the ability to access your detection code base, can do a great job of doing coverage analysis. They're also really good at taking threat intelligence reporting, reprocessing that, and then figuring out where you potentially have gaps or coverage. And they're also great at answering really lazy questions. So if your manager pings you and says, hey, do we have coverage for that vulnerability in our Azure environment? You can literally just copy and paste that message into an AI-assisted tool and be able to get a very quick answer. They're also great at answering vague questions like, is US East 1 broken today? And they can get you an answer very, very quickly. And finally, we've also been using large language models to tune and improve our detection rules. So we can take false positive feedback from our incident response team and our SOC, and we've been able to use MCP and some vibe coding tools to essentially automate the process of tuning false positives. We have also found that LLMs are really effective at creating additional true positive and false positive test cases. So if we've envisioned certain scenarios where a false positive may occur, they're able to go in and provide additional context. That's been very, very helpful. So anyway, I hope this gives you some ideas for how you might be able to use these tools in your environment, and really appreciate your attention. Thank you. The question was, it seems like there's a use case for LLMs to be able to answer questions from auditors. I would completely agree. In fact, I would argue that you could take most of the content you're receiving from auditors as well as internal documentation and have the LLMs be able to largely automate that process and potentially anticipate things that they haven't asked you about yet, but they may ask you about in the future. So, yeah. Yes.
Other than, seems like a legit company, how do you vet which MCPs are safe and which MCPs?
Yeah, great question. So the question was, how do you vet which MCP servers are safe to use? So I think this is largely a software supply chain problem. As an individual practitioner, I would encourage you to look at where the MCP server is coming from. Is this coming from someone's personal GitHub page where they have implemented their own PagerDuty MCP service, or is this coming from PagerDuty themselves? Also, really common like software hygiene things like how many bug reports are open on this GitHub repository? Do they have kind of CI/CD tests that are validating the code when it's published? Ultimately, at the end of the day, though, I think that the best option is, one, ensure your legal team is signed on with you taking the data that you're working with and using it in this context. And two, only use these things in a read-only capability. So we aren't allowing these tools to take any actions on our behalf yet. We're simply using them to speed up our response process.
I had a question kind of along those lines. You mentioned having it log into PagerDuty and some of the other services. Are you creating a new account that's a read-only account for that sort of service, or is this usually like your own actual account?
Yeah, that's a great question. So Databricks is a little unique because we're actually a model serving provider. We allow companies to host large language models on our infrastructure. So when we're working with internal security data, we're actually using models that we host. In this case, though, with the example that I gave, that's actually running in Claude under the context of my personal account. So it's essentially piggybacking on the credentials that I have already set up to be able to act in that way. So I think the answer is both, but it's going to depend on your environment.
Hello, thanks for a very great presentation. I was just wondering from an audit point of view, when you have an agent or an MCP server logging in on your behalf, does it identify that request as being from not from you personally?
Yeah, that's a great question. So I think it's going to depend on the logging that you have with your SaaS provider. There's a lot of challenges with SaaS provider logs. And so like, for instance, when I'm logging into PagerDuty, you'll see my Chrome user agent. You'll see my user having gone through the process of tapping my UB key several times and kind of going through the OAuth flow. When these services are interacting, it's coming from source code, right? So either a Python UA or a UA associated with the MCP server. So I think it'll largely depend on your environment. But again, if you're going to go production with this, I would encourage you to use service accounts, in which case it becomes very auditable. All right. I think that's all the time we have. Thank you so much.
Thank you, guys. Give it up for Will.